Good morning everyone. Today I am going to discuss about the topic polymer processing. Polymer processing is a technique to convert polymer into a broad spectrum of useful shapes and structures. As per application of the polymeric materials, they are converted into required shape and size by applying different processes. Types of processing. There are four types. First, thermoforming, second, calendering, third, casting, where casting is divided into die casting, rotational casting, film casting, and fourth is molding, where molding is divided into compression and transfer molding, rotational molding and sintering, extrusion molding, injection molding, blow molding. Thermoforming. Thermoforming is a highly useful process for fabricating three-dimensional articles from plastic sheets. In this technique, the thermoplastic sheet is heated to its softening temperature. The warm flexible sheet is then pressed into the female half of a matched metal die duly assisted by the male half. On cooling, the shaped article becomes rigid and can be removed from the mold. Application. Food-related applications such as meat trays, microwave and deep freeze containers, ice cream and margarine tubs, snack tubs, bakery and patisserie packaging, sandwich packs and vending drink cups. Manufacturing, collation trays, blister packaging and point of sale display trays. Calendering. The calendering process is employed to produce continuous films and sheets. The calendering machine contains a set of highly polished metal rollers rotating in opposite direction with provision for precise adjustment of gap between them. The gap between the rollers determines the thickness of the sheet that calendered out. The compounded polymeric material is fed between the rollers which are maintained at an elevated temperature. The sheet emerging from rollers is cooled by passing through the cold rollers. The sheets are finally wound up in rolls. The polymers which are mainly calendered into sheet are PVC, polyethylene, acrylonitrile butadiene styrene and rubber. Casting. Casting is the process in which liquid polymeric material is poured into mold. The mold contains a hollow cavity of the desired shape and size. The molded material is allowed to cool to make the solid. The solidified part is known as casting, which is ejected out of the mold to complete the process. Mainly, three types of casting techniques are known: die casting, rotational casting, film casting. Die casting. The pre-polymer compounded material with a creative and other ingredient are poured into a petri dish. The petri dish is then kept into oven at an elevated temperature to cure the polymeric material. On cooling at room temperature, the solid product from the petri dish is pulled out. For the product in cylindrical shape, we use cylindrical die. Polymerization is allowed to continue inside the die till the solid product is formed. Acrylics, epoxies, polyester and polyurethanes are suitable polymeric material for die casting. Rotational casting. Rotational casting is used to produce halo articles such as ball, dolls and rain boots. The compounded thermoplastic material in the form of a fine powder is taken in the halo mold. There is a provision to rotate the mold simultaneously along the primary and secondary axis. After casting the mold, it is heated and rotated. This process distributes the molten plastic uniformly along the entire surface of the inside cavity of the mold. After some time, the mold is chilled with cold water under rotation and solidifies in the shape of the surface. Film casting. The polymer solution in an appropriate concentration in a suitable solvent is allowed to fall at a certain rate on an endless metallic belt at a constant speed. Thus, the polymeric solution is spread over the metallic belt in the form of sheet. At the metallic belt, the solvent undergoes evaporation and polymer is converted into hard sheet. Compression and transfer molding. A pre-weighed amount of material is placed in a matched metal mold and the mold is closed. It is then subjected to heat and pressure. The material is liquefied and flew into the voids in the tool where it chemically reacts and hardens into the final shape. Very large shapes can be molded in compression presses. Advantages of compression molding: low scrap arisings, low orientation in the molding, low residual stress products, low mold maintenance, low capital and tooling costs. Rotational molding and sintering. Rotational molding uses relatively low cost molds and processes polymer at very low shear rates. The material experiences higher temperatures for longer times than other process methods. Very stable parts and low tooling cost for large parts, suited for low volume production, can produce complex part geometries, can mold in metal inserts and graphics. Current area of uses: storage tanks of various sizes, trash can, boat hulls, bucket housing, large hollow toys, football. Extrusion molding. It is one of the cheapest methods for producing many common plastic products of continuous lengths such as films, filaments, tubes, sheets, pipes, rods, hoses, and straps. In the machine, the compounded plastic material is fed through the hopper as either powder or granules into a cylinder having provision for electrical heating for softening the material. The hot plastic is further passed through the cylinder by a helically flighted revolving screw. During its journey from the hopper to the die, the plastic material passes through distinct zones named feed zone, compression zone, and metering zone. For cooling process, cold air blast and cold water spray are used. The product formed is cut to the desired length or wound onto rolls. Advantages: part cost low, tool cost low, production capability high, short lead times to production, uniform cross section of parts, multiple materials are possible in the same part. Injection molding. In this molding process, a definite quantity of compounded plastic materials are fed in the form of granules, pellets, or powder through hopper at a definite time intervals into a net horizontal cylinder where it gets softened. The hot zone of the cylinder, called torpedo, helps to spread the plastic material uniformly around the inside wall of the hot cylinder. Now the material is injected with the help of a piston at the pressure about 1500 kg per centimeter square. After the mold is filled with the molten material under pressure, it is cooled by cold water circulation and then opened to take out the mold articles. Blow molding. Blow molding basically belongs to the glass industry. A hot softened thermoplastic tube, usually called parison, is properly placed inside a two-piece hollow mold. When the two halves of the mold are closed, it pinches and closes one end of the parison and encloses a blowing pin at the other end. The parison is now blown by blowing compressed air through the blowing pin. The hot parison is inflated like a balloon and goes on expanding until it comes in intimate contact with the relatively cold interior surface of the hollow mold. The mold is allowed to cool and the rigid thermoplastic article formed is removed by opening the mold.